Hey guys, this is for exam wrapper number 2. I will be doing question 2B of our last exam. The question states that assuming friction is negligible, what is the speed of the mass when the spring returns to its relaxed length? So this question originally had a little picture, but I pulled the necessary information in this little corner right here. And using that information and physics, we can get to the answer. So as always, we're going to start from a fundamental principle, and in this case, we're going to use the energy principle. So delta E, in this case, only involves the change in kinetic energy and the change in the potential energy of the spring. And since no work is being done on our system, we can assume delta E equals 0. So let's just jot down some formulas that we're going to use. The formula for U spring equals 1/2 the spring constant times the change from the relaxed length squared. And then the formula for kinetic energy equals 1/2 mass times speed squared. Okay? So now we can expand this formula to the final minus initial forms. So we have KE final minus KE initial plus U spring final minus U spring initial equaling 0. And we can move half of these to the other side. So we have KE final minus KE initial equals negative U spring final plus U spring initial. Okay? And since the question states that we're looking for the speed of the mass when the spring returns to its relaxed length, we can assume that the final spring potential goes to 0. Because when there's no change from its relaxed length, the spring potential energy will be 0. I apologize for some shaking. So now we can plug in our actual numerical formulas to where 1/2 mass times the final velocity squared minus 1/2 mass times the initial velocity squared equals just 1/2 k times the distance from the relaxed length squared. And now we can plug in all the values because we can define everything except for the final velocity, which is what we're looking for. So plugging in everything, we see 1/2 times 0.4 times Vf squared minus 1/2 times 0.4 times the initial velocity of 3 squared equaling 1/2 times the spring constant times the distance from relaxed length squared. Okay? And since we only have one variable to solve for now, we can just perform all of this in our calculator. And the final answer that we should find is that the magnitude of the final velocity will equal 4.07 meters per second approximately. Alright, I hope this helps out anyone that was confused with this problem. Looking at it starting from a fundamental principle, this seems pretty straightforward. Alright, that's it for this video for exam wrapper number 2. Thank you for your time.